Now let's talk about the last case where object is kept between F1 and O, that is placed within focal length or sometimes placed very close to it. So I have drawn an object AB, you can see perpendicular to principal axis, and it is kept between F1 and O, and I have drawn two incident rays which are standard, one parallel to principal axis, other passing through optical center. So if I draw the refracted rays, so this parallel ray after refraction will pass through F2. We can see the path, and this ray passing through optical center will go undeviated. We know the path of this ray. Now can I say these rays are diverging? That means these rays will never meet at a point. Parallel rays will meet at infinity, but diverging rays would never meet. So what we have to do over here, we have to trace this ray backward. That means these are imaginary rays. These are not real rays because these rays are traced backward. And if I draw the rays backward, okay, so these rays are appear to be intersecting at some point, and that is the point where the image is formed. So if I talk about image, so the image here is formed, can I say, remember the image is shown by big dotted lines, whereas in the previous cases I shown the image by a single line, because that image was the real image. Now you can see here that this image, that means let's name it A1 B1, the image is not formed due to the actual intersection. That means this image is formed, okay, when the refracted rays were traced backward. So this image is not formed due to the actual intersection of the refracted rays. So the nature of image, if I say, then this image will be virtual. So this is the first case where we have obtained a virtual image, okay, and virtual image is always erect, because you can see the arrow in the image is upward, and even in the object it is upward, and we can say it is magnified. So it is virtual, erect and magnified. Virtual, erect and magnified. And if I talk about the position of image, so for position of image we have to say the image is formed on the same side of object, but where it is formed? It is formed behind the object. We have to say it is formed same side, it is formed same side as object, image is formed on same side as object, right? But remember, it is behind the object, because if I try to see an object, okay, by convex lens placed very close, so images will form behind the object, right? So this is the case. And if I talk about one applications of this case, it is very important that it is used as a simple microscope, or it is used as a, we can say, doctor's mirror. So whenever doctors see your tongue in a clinic, he always uses a magnifying glass. So the application of this position is that it is used as simple microscope, or I would better say as a magnifying glass. And why it is used as a magnifying glass? Simply because the object is image is magnified with respect to object, but important to that, it is erect, and whenever we see the erect image, it will not create any kind of confusion. So this application is very important in case of convex lens, and these ray diagrams are asked, this diagram is asked so many times in exams. Sometimes there is a special question where we have to form the image using the third ray. So I have already used the two ray, one traveling parallel, other passing through optical center. If I have to make use of third ray, so what I'll do, I'll extend this optic axis. Remember, this is imaginary, okay? I can extend this axis, and the third rule says that the ray should pass through F1. So what I will take, a ray passing through F1, but this ray is originating from object A, but it is assumed to be coming from F1, you can say. And if a ray passes through F1, then after refraction you know that it will travel parallel to principal axis, and if I trace it backward, you can clearly see, if I trace it backward, you can clearly see that it is meeting at this point. So this is the third ray. Okay, I will suggest you not to use this third ray unless it is asked, right? So this case, when the object is kept between F1 and O or within focal length, the image is formed on same side as object, that is behind the object, and the image is virtual, erect and magnified. It is used as simple microscope or a magnifying glass. So remember, in case of convex lens, there were 6 positions of object. For the first 5 positions of object, the image was real inverted. And what conclusion we can draw from all this ray diagram, that real image is always formed on the other side of the lens. That means on the left side if there is an object, and if image is formed on the right side, it will always be real and inverted. And if the image is formed on the same side, then definitely this image will be virtual and erect.